In today's video, we're going to talk about reference types. As we have already talked about primitive types, and in primitive types we store simple data like number, floating numbers, character, boolean. But when it comes to reference types, we use those data types for store complex data. And in reference types, there is something special about memory allocation, which we also need to learn. So in this video, I'm going to teach you what is the reference types, how we can declare them, and how the memory allocation is actually work. So let's dive into it. So in here we have declared our own class, which is a human class, and inside that human class we have declared some properties. Like here we have declared a method which is called functionalities. This is actually saying what is the functionalities a human actually got. Like here we have written system.out.println my name is plus name. Here we are saying that what is the name of that person. So if we want, we can also add other functionalities like what is that person's hobby, and we store them inside a variable, and we write that variable in the parameter section. So now if I want to run that class, we need to create an object of that human class. So now if I create an object person1 new human, and if I declare values inside that functionality method, so now if we run this code, now here we are giving two values. One is my name is John, and another is the hobby of this person is to garden. So we are getting this value from this method here, and in here we are writing new. So that means that we are assigning memory for this class human, and person1 is the object name, and you can also say that as an instance, as a blueprint. So this blueprint is actually saying what is the properties and what is the functionality, what is the method this person got. So one person got one kind of functionalities and another person got different kind of functionalities. So we can differentiate two different person very easily. And here we have used public, that's why we can access that method. But if we use private here, then we have to use getters and setters. And private, public, protected, these are called access modifier, and we will talk about this topic in some other video. But when we declare and initialize values in using the primitive data types, we don't have to allocate memory like this, like reference types. So there is a difference in between primitive types and reference types when it comes to memory allocation. In primitive types we don't have to allocate the memory, but in reference types we have to allocate the memory. And after we allocate the memory, it is actually managed by the Java runtime environment. And here I have import a package which is called java.awt.asterisk, and it is giving me a warning because I haven't used any classes of that package. So there is a thing which is called package, and inside that package we got classes, and we got some predefined classes. We can also write classes on our own, and the class we have we can add functionalities to that class, we can add properties, we can add methods, and we can do whatever we want it to do. And when it comes to predefined classes, we got some properties, we got some methods inside that class, and to use that predefined class we have to import it. So here I have import java.awt.asterisk. So that means I want to use a class of the package Java, and which is the parent, and its child is awt, and from that child package awt I want every classes of that package. So now if I use one class of the java.awt package, then the warning will be gone. The warning is actually saying that I have never used it, so that's why it is giving me error. So we have declared an instance or object of using a class point. So now you can see the warning has gone, but now it is giving us a new warning, which is this value of the local variable p is not used. If we use the object p, then this warning will also be gone. So now let's come to the topic, which is called memory allocation. So in memory allocation, when it comes to reference types, we have to allocate the memory, and when we allocate a memory using primitive types like int x equals to 5, and now if I declare another variable and assign the x value inside of it, then if I increment the if I enhance the value of x, and now if we print out x and then y, now if we run our code, we are finding two different values. One is 6 and one is 5. But I have stored the x value inside y. But why this is happening? Because see, when a variable is declared using the primitive data types, the variable is independent. It is not dependent on other variables. So when you increase the value of x, it doesn't affect on y variable. But if we declare this line of code right before the initialization of y, so now let's see what is the output we got. So here we are finding the same value, because before the initialization I have increased the value of x. That's why this is giving us the same value. But when it comes to reference types, no matter where we initialize our value, it doesn't matter. It will affect throughout the program. So if you are not understanding what I'm trying to say, I will give you an example by writing a code. So in here we have declared a object of point, and inside that object, now if we change the value of x, and now if we declared another object with the name of p1 and initialize it with the p value, and now if we change the value of p, now if we print out the value of p along with the p1, we're getting the same value. So in this example, we declare two objects. One is p and another is p1, and then we initialize the p1 value as the p value. So here we have we are actually doing is we are storing a reference to an object somewhere in the memory. So in this example, p and p1 are referencing the exact same point object in memory. We only have one point object, so these two variables are not independent of each other. They are referencing the same object And that means if I update the point object through either of these variables, the changes will be visible to the other variable. So that's why when we are changing one value, it get also changed the other value, no matter where we write our code. But it's true, you have to change that value right before we print out our code. Otherwise, we will be getting the previous value, not the new value.